Welcome to physics class. My name is Gias Uddin. My dear students, in the previous classes we have already learned about Devission Germer experiment. So today we are going to discuss about some important numerical based on Devission Germer experiment. Okay, so this is our first problem. In Devission Germer experiment, the diffracted electron were obtained at an angle of 65 degree, that is theta equals 65 degree, from nickel crystal if the diffracting interplanar distance is 0.91 angstrom. Find de Broglie wavelength of electron for first order diffraction. Okay, so we are going to solve this problem. The given information of this question, solution given, this is diffracted angle, so this is theta equal 65 degree, and interplanar distance, generally interplanar distance is also called d equal distance between two successive layers of the atom. From Bragg's law we can say that this is the interplanar distance. Okay, so d equal 0.91 angstrom. We know that angstrom is not SI unit of wavelength, so it should be converted in SI system. So we can write 0.91 into 10 to the power minus 10 meter. Since 1 angstrom equal 10 to the power minus 10 meter, so we can write 0.91 angstrom equal 0.91 into 10 to the power minus 10 meter. Okay, and find the de Broglie wavelength of the electron for first order diffraction. So for first order diffraction, this is integer number n equal 1 and lambda equal what? So this is our given data of this question. Okay, now we know that by using Bragg's law, this is called Bragg's law. Okay, from Bragg's law we can say that 2d sin theta equal n lambda. Okay, this is called Bragg's law or Bragg's equation. 2d sin theta equal n lambda, and lambda equal 2d sin theta divided by n. The value of d equal 2 into 0.91 into 10 to the power minus 10 and sin 65 degree. Okay, this is sin 65 degree divided by n equal 1. Okay, so 2 into 0.91 into 10 to the power minus 10 into sin 60, the value of sin 65 degree, the value of sin 65 degree is 0.906. So finally we can write 1.65 into 10 to the power minus 10 meter, 1.65 into 10 to the minus 10 meter, and this is equal to 1.65 angstrom. So this is the required wavelength of the electron. For your better understanding, I am going to repeat it once again. In Devission, the statement of this question like this: that in Devission Germer experiment, the diffracted electron were obtained at an angle 65 degree. This is diffracted angle, and that is equal to theta equal to 65 degree from nickel crystal. Okay, from nickel crystal. If the diffracted interplanar space or distance is 0.91 angstrom, find the de Broglie wavelength of the electron for first order diffraction. Okay, from this question, from this numerical problem, the given data are theta equal 65 degree and d, this is called interplanar space. Okay, 0.91 angstrom, and 1 angstrom equal 10 to the minus 10 meter. So we can write 0.91 into 10 to the minus 10 meter, and this is the first order number. So n equal 1 and lambda equal what? We know that from Bragg's equation we can write 2d sin theta equal n lambda, and lambda equal 2d sin theta by n. When all the values substituted in this equation, then we can say that lambda equal, we can write this lambda equal 1.65 into 65 angstrom. Okay. One important diagram here. This is electron beam, incident electron beam, and this is scattered beam. Okay, and this is diffracted angle, and d equal distance between two successive layer of a atom. Distance d equal distance between two successive layer of atom, or we can say that interplanar space between two layer of the atom. Okay, and theta glancing angle, or also we can say that angle between scattered beam and plane of a crystal, and n is integer number and lambda wavelength associated with wave, that means electron. Okay, Okay, our next problem is Monochromatic X-rays when reflected from a crystal with a lattice spacing 2.0 angstrom produced. Okay, first order diffraction, maximum at an angle theta equal 30 degree. What is the wavelength of X-ray? So this is also based on Bragg's equation, okay, or Bragg's law. Solution: the given information of this question. Solution: given theta equal 30 degree, yes, theta equal 30 degree, and interplanar space d equal 2.0 angstrom, and 2.0 angstrom, that means 10 to the power minus 10 meter, because we know that angstrom is not SI unit of the wavelength, so it should be converted in SI system. So 2.0 angstrom equal 2.0 into 10 to the minus 10 meter, because we know that 1 angstrom equal 10 to the minus 10 meter. Okay, and this is first order, so n equal, for first order n equal 1 and lambda equal what? So again we can apply Bragg's law. We know that twice the sin theta equal n lambda, twice the sin theta equal n lambda. So lambda equal 2d sin theta divided by n. Okay, 2 into d equal 2.0, that means 2.0 into 10 to the minus 10, and sin 30 degree, that means this is equal to half. 2 and 2 cancel to each other, and divided by n equal 1. So finally we can write 2.0 into 10 to the power minus 10 meter, and this is equal to 2 angstrom. Okay, so our required wavelength is lambda equal 2 angstrom. For your better understanding, I am going to repeat it once again. Monochromatic light X-rays when reflected from a crystal with lattice spacing 2.0 angstrom produce first order diffraction, maximum at an angle 30 degree. What is the wavelength of X-ray? From this question, the given data, theta equal 30 degree and d equal interplanar space, or we can say the distance between two successive layers of the atom. This is denoted by d, and n equal 1 for first order, and lambda equal what? We know that from Bragg's equation 2d sin theta equal n lambda, and lambda equal 2d sin theta divided by n. When all the values substituted in this equation, then we can write lambda equal 2. After solving this part, we will get lambda equal to angstrom. Okay. 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 Our next problem is this: a electron skirted through 100 volt reflected from a crystal. Calculate the glancing angle at which the first order reflection occurs, given lattice spacing is 2.15 angstrom. Now I am going to solve this problem. Solution: given the given information of this question, this is lattice spacing, it means that this is d equal 2.15 angstrom, and we can write 2.15. This is not, angstrom is not SI unit of distance, so it should be converted in SI system. So 10 to the power minus 10 meter. Okay, and 100 volt, B equal 100 volt, and this is clear that particle is electron. Okay, particle is electron, so charge of electron equal Q equal 1.6 into 10 to the power minus 19 coulomb, and mass of electron equal also 9.1 into 10 to the power minus 31 kg. Okay, and Planck constant also 6.62 into 10 to the power minus 34 joule second. Okay, and calculate the glancing angle, that means theta equal what? That means theta equal what? Okay, so first of all we are going to find out the lambda by using de Broglie wavelength in terms of voltage. Okay, solution: we have by using de Broglie wavelength of electron in terms of potential difference. Okay, so lambda equal h by under root of 2m qb. Okay, the value of h equal 6.62 into 10 to the minus 34, and under root of 2 into 9.1 into 10 to the power minus 31 into 1.6 into 10 to the power 19 into b means 100. Okay, this is equal to 100 volt. After solving this part, we will get 1.229 into 10 to the power minus 10 meter. 10 to the power minus 10 meter, and this is equal to, we can write 1.2 to 9 into 9 angstrom, because we know that 10 to the power minus 10 meter equal 1 angstrom, so we can say that 1.2 to 9 angstrom. Okay, now we are going to find out glancing angle. Now glancing angle we can find out with the help of Bragg's equation. Okay, so again we have 2d sin theta equal n lambda, and sin theta equal n lambda divided by 2d, and theta equal sin inverse n lambda divided by 2d. Okay. Now theta equal sin inverse n lambda, n equal 1, and lambda equal 1.2 to 9 into 10 to the power minus 10, and divided by 2 into d. The value of d is equal to 2.15 into 10 to the minus 10. After solving this part, we will get theta equal, this is sin inverse, theta equal 16.61 degree. So this is our required glancing angle. For your better understanding, I am going to repeat it once again. An electron skirted through 100 volt potential difference reflected from a crystal. Calculate the glancing angle at which the first order reflection occurs given lattice spacing 2.15 angstrom. Okay, from this question, the given information of this question, say this is spacing, lattice spacing, this is d, that means distance, lattice spacing, and also this is 100 volt B, so B equal 100 volt, lattice spacing 2.15 angstrom, H equal Planck constant. Okay, first of all we are going to find out lambda equal H by under root of 2 m3b. This is called de Broglie wavelength in terms of the voltage. And secondly, we can say that from Bragg's equation, 2d sin theta equal n lambda, and sin theta equal n lambda divided by 2, and theta equal sin inverse 1. Sin inverse within bracket n lambda divided by 2d. Okay, when all the values substituted in this equation, then we will get theta equal 16.61 degree. Okay. Okay, our next problem is an electron accelerated through 1000 volt is reflected from a crystal. The first order reflection occurs when glancing angle is 70 degree, and calculate the interplanar spacing of the crystal. Okay, so the given information of this question, solution, given particle is electron, this is already clear. This is clear that electron particle is electron. So mass of electron 9.1 into 10 to the power minus 31 kg, and H equal Planck constant 6.62 into 10 to the minus 34 joule second, and Q charge on electron 1.6 into 10 to the power minus 19 coulomb, and glancing angle is also theta equal 70 degree, and potential difference, accelerated potential is V equal 1000 volt. Okay, first of all we are going to find out wavelength of electron, and for wavelength of electron we can apply de Broglie wavelength in terms of potential difference of the particle. Okay, so we know that lambda equal H by under root of 2m qb. This is the expression of de Broglie wavelength in terms of electron or charged particle. Okay, so lambda equal, the value of H equal 6.62 into 10 to the power minus 34, and under root of 2 into mass of electron 9.1 into 10 to the power minus 31, charge of electron 1.6 into 10 to the power minus 19, and potential difference 1000. After solving this part, we will get 3.885 into 10 to the power minus 11 meter. So this is our required wavelength. Now we are going to find out interplanar space. Okay, so again we can apply Bragg's law. Again we know that twice d sin theta equal n lambda and d equal n lambda divided by twice sin theta. Okay, so the value of n for first order n equal 1 and lambda this is equal to 3.885 into 10 to the power minus 11 and divided by 2 into sin 75 degree, sin 70 degree. Okay, theta equal 70 degree. And 1 into 3.885 into 10 to the power minus 11 into 2 into sin 70 degree, almost 0.0393. Okay, after solving this part we will get 0.2067 into 10 to the power minus 10 and this is equal to 0.2067 angstrom. So this is the required interplanar spacing. Okay, so this is equal to D. Okay, our last numerical problem is the statement of this numerical. An electron beam is accelerated from a rest through a potential difference of 200 volt. First part, calculate the associated wavelength, and second part, the beam is passed through a diffraction grating of spacing 3 angstrom. At what angle deviating from the incident direction will be the first maximum observed? Okay, so the given data of this question, generally this question consists with a two part. This is first part and this is second part. First part we are going to find out wavelength. Okay, solution. Given particle is electron, this is clear that. Okay, so mass of electron 9.1 into 10 to the power minus 31 kg and charge of electron 1.6 into 10 to the power minus 19 coulomb and accelerated potential B equal 200 volt. Okay, 200 volt and interplaning spacing 3 angstrom. This is D equal 3 angstrom and angstrom equal 3 into 10 to the power minus 10 meter, because we know that 1 angstrom equal 10 to the minus 10 meter. Okay, now we are going to find out wavelength associated with electron. We know that from de Broglie wave equation we know that lambda equal h by under root of 2m qb. Okay, the value of h equal 6.62 into 10 to the power minus 34 and the value of m 2 into m 9.1 into 10 to the power minus 31 into q 1.6 into 10 to the minus 19 into b accelerator voltage, this is equal to 200 volt. Okay, 200. Okay, after solving this part we will get the result is 0.8688 into 10 to the power minus 10 meter and this is equal to 0.8688 angstrom, because we know that 1 angstrom equal 10 to the minus 10 meter. So this is our required wavelength associated with electron. Now we are going to solve second part. Second part, we have 2d sin theta equal, this is called Bragg equation, 2d sin theta equal n lambda, theta equal what? That means glancing angle. So theta equal n lambda divided by 2d sin theta, 2d n lambda divided by 2d sin theta equal n lambda divided by 2d, and next we can write theta equal sin inverse n lambda divided by 2d. Now we are going to put all the values in this equation. Sin inverse n, this is first order, so for first order n equal 1 into lambda, lambda is equal to 0.8688 into 10 to the power minus 10 and divided by 2d. D, this is equal to 3 into 10 to the power minus 10. After solving this part, we will get theta equal 8.32 degree. Theta equal 8.32 degree. So this is the required value of theta. Okay, thank you.